Today's learning target is I can determine relationships of angles formed by parallel lines and a transversal. This is going to be the first lesson in our geometry unit, and you're going to find that there's going to be quite a bit of vocabulary. So what I would like you to do during this chapter is there are going to be pictures that will be helpful for you to keep somewhere so that you're going to be able to study for these as you go. So for example, we've got a picture right here that came from our book on page 589, and what you should do is go to page 589, take a picture of this in either Notability or maybe Explain Everything, someplace where you can keep multiple pictures from this unit so that when we get to the end of the unit, you have something to study from. So we are going to need to know all of these vocabulary words. We're also going to have some others coming up here later, but let's start right here with vertical angles. So vertical angles are made when you have two lines that intersect, or two lines that cross, and they are the angles that are opposite of each other. So 1 and 2 are vertical angles, you can see that here, as are 3 and 4, because they're opposite. So over here we see that angle 1 is congruent, this sign means congruent, to angle 2. Remember, congruent means the same. So 1 and 2 are the same, and angle 3 and 4 are the same. Now, adjacent angles are angles that are right next to each other, just like these two, angle 5 and 6, and they share the same vertex. So our vertex is right here, it's this point, and we can see that to write this, we'd see the measure of angle ABC, this angle. Remember, B, when we write this angle, has to be in the middle because that's the vertex. And that's equal to the measure of angle 5 and the measure of angle 6. Complementary angles are two angles that when you add them together, they're going to make a right angle, or 90 degrees. So that's how we can show that. The measure of angle 7 and the measure of angle 8 are going to equal 90 degrees. Supplementary angles are similar to complementary angles, except they are two angles, and those angles equal 180 degrees. So the way I remember this is complementary starts with a C, that comes earlier in the alphabet, and 90 comes before 180. S comes later in the alphabet, and 180 comes after 90. So that's how I keep track of which is complementary and which is supplementary. And lastly, on this slide, we have perpendicular lines, and you probably remember perpendicular means that we have lines that when they cross, they make a 90-degree angle. So the symbol for showing something is perpendicular is right here, this upside down T. So I can use my knowledge of the different kinds of angles to help me solve problems. So let me give you an example here. Let's say that we know that the measurement of this angle is 130 degrees. Now, right here is a straight angle, and I know a straight angle is 180 degrees. So if I wanted to find the measurement of x, I could just do 180 and subtract 130 degrees, and I would get 50 degrees. So I know that x would be 50 degrees. All right, we have another picture here that we should add into wherever it is that you're saving your project here. And this is on page 590. Okay, and it covers two things. One you're probably familiar with, parallel lines. All right, so parallel lines are, you probably remember this from previous years, lines that will never cross. You can extend them and they'll never cross. We show parallel lines like this using this symbol. So S is parallel to T in this case. Now the other word that we're going to talk about here that might be new to you is a transversal. And R, line R, is a transversal. And that is when parallel lines are cut, or when a line goes through parallel lines. One way that you can remember what a transversal is the prefix trans means across. Like transcontinental means across the continent. If you translate something, you put it from one language across into another language. And so a transversal crosses those parallel lines. All right, you're also going to want to get this picture in here. This is going to talk about some new things that I know that you're not familiar with. This is also on page 590, so take a picture of this as well. So when we have a transversal, like we have here, that cuts or intersects our parallel lines, it ends up making 8 angles. We can see those angles right here. Now, the angles that lie on the inside are called interior angles. So angles 3, 4, 5, and 6 are interior. In means inside, because they are inside of the parallel lines. And then angles 1, 2, 7, and 8 are exterior. The prefix X means out, like exit, means outside. And those would be 1, 2, 7, and 8. So when we have a transversal that intersects parallel lines, it makes some special kinds of angles. One type of angle is called alternate interior angles. Sounds complex here, but we know interior angles are the inside angles, okay? And the alternate interior angles are the angles in the inside that are congruent to each other, okay? Or they're the same. So we can see in the inside angles, here are our 4, 3 and 5 are the same size, okay? They're going to be the same measurement. So those alternate interior angles for 3 and 5 are congruent. Okay, same thing with 6, angle 6 and angle 4. Those are alternate interior angles. They're congruent. Now we also have alternate exterior angles. So those angles that are on the outside there, we have ones that are congruent. So we can see angle 1 and 7. There's 1, there's 7. You can see those are the same. They're going to be congruent. They'll be the same number of degrees, as will angle 8 and angle 2. We also have corresponding angles. Okay, now these angles are angles that are in the same position in relation to the transversal. So for example, angle 1 and 5. See how they're both on top of the parallel lines, and they're this angle right here. So those are corresponding angles. Angle 4 and angle 8 would be corresponding. They're in the same position in relation to this transversal. Okay, 7 and 3 are corresponding, and 6 and 2 are corresponding. Now the difference between the corresponding and our alternate interior and exterior angles, when we look at the alternate interior angles, those are only our inside angles. The exteriors are only the angles on the outside. Corresponding deal with 1 in the inside, in this case, and 1 on the outside. Okay, so you can see that's the relationship for each of these corresponding angles. One's on the inside, one's on the outside. So we can use all that information to help us find the measure of angles when we have parallel lines. So here we can see that A and B are parallel to each other. These arrows also show that. And Q and R are the transversals. They go through those parallels. Now if we're asked to classify the relationship between angles, like we are here, between angle 3 and 5, it's basically saying, what do we know about these? So we know that 3 here and 5 here are interior, right? They're on the inside of the parallel lines. And we also see that they alternate. There's one here and one over there. So we know they're alternate interior angles, and we also know by that they're congruent, or the same. If they give us the measurement of an angle like this, and we have transversals and parallel lines, so the measurement of angle 1 is 120 degrees, I know that this vertical angle, angle 3, is going to be the same, because I know vertical angles are congruent. Okay? I also know that my corresponding angles here, 1 and 5, are also congruent. So 5 is also going to be 120 degrees. And for this lesson, you're probably going to have to go back until you become familiar with these terms, but that's where having your iPad and those pictures will help you with your assignment. The last thing we're going to do today is to use algebra in our geometry unit to help us figure out the measurement of certain angles. So here we know that the measurement of ABD right here is 164 degrees. Now these two angles right here and this angle right here are going to equal 164 degrees. So I'm going to take the measurement of one angle, which is 2x plus 23, and I'm going to add that to the measurement of this angle right here, which is x, and I know that those two angles together equal 164 degrees. So when I put these two angles together, they have to equal 164 degrees. That's what I've shown. Next, I combine my like terms. So I've got an x and a 2x here, which makes 3x plus 23 equals 164. Now before I can get x by itself, I have to get rid of my 23, so I subtract 23 from both sides, cancels out, and I'm left with 141 over here, which is equal to 3x, and now I divide both sides by 3. So that leaves me with x equals 47. So now that I know that, I can go back up here to take a look. I see that x is angle CBD, so angle CBD equals 47 degrees. And now I see that angle ABC, I can see I'm going to have to plug in x to this to figure out what that angle equals. So you can see that I've done that right here. Okay, I saw that 2x, so 2 times x is 47, added 43. I worked that out and I got 117 degrees.